We're at the year 3 of the ATE demonstration. COVID impacted the first 2 years, so this is our opportunity to demonstrate all the progress that the team has made, developing various capabilities for exploiting underground facilities. What we've set out to do is develop a payload that provides the capability to autonomously exploit underground facilities, as well as bring in additional sensor data to provide a broader operational understanding, environmental understanding of the sub-T through the payload that can be integrated across multiple platforms. In order to do that effectively, we've contracted Asymmetric Solutions, who have a wealth of knowledge from their prior military experience across all services conducting these type of missions, so that they can execute it in a realistic way and give us honest feedback for how effective this capability is to do this mission moving forward.
The exercise that we're executing, we actually come upon a portal to what appears to be a tunnel system, and then we are supposed to basically do a reconnaissance of this tunnel system to see if it is abandoned, because ISR overhead, lets us know that it appears that there's been no activity there, so it appears to be abandoned. But we need to verify that. So we don't have any we're not currently wearing any breathing apparatuses, closed circuit or open circuit or a combination of the both. So we've come along with this, but we have the technology, so we're going to go ahead and do a reconnaissance of it. So what we're going to do is we're going to use the technology, so we're going to come up on what we call our LCC, is our last cover and concealment. And then we're going to come along and we're going to bring technology up to that portal, and we're going to be in a safe area, and we're going to let the technology actually take a look at the portal. If there's a door there, take a look at what it is, and we should see that before we even get close to that. If it's open, then we're just going to go ahead and send it in a certain amount of distance, and depending on the layout, we'll start to put it into what we're now seeing is this exploratory mode, where it actually goes on its own and then just looks around, identifies everything, and then it maps it out as well at the same time. So after that's done and it's gone through, then now that we know the mapping, we basically know the overlay, the overhead, like we would for any target, we've got that underground, which we've never had before. We've never had that before. We can't get it from the sky. So now we have it, and it's with us. So now we'll bring it back to us. We'll come up, we'll approach, we'll identify that the technology is there. It's done exploratory. We've already got our layout. We know what's in there. We know what we need to do to mitigate it. And then we come up with our plan for our TTPs, and then we tactically move on to the tunnel to take it down.
So we brought 3 different platforms that we're demonstrating this year. We've done the majority of our work on the ground vehicle robotics, the GVR bot. That's a research and development platform that we mount our payload on, and then we can develop our software, we develop our algorithms, and then order using the robotic operating system. We use standard interfaces to order that platform to move in certain directions. And using those same interfaces, we can use our Boston Dynamics Spot platforms, and then we can also use our MTRS Inc. 2, the Army's medium-sized ground robot. And using those identical interfaces to the GVR bot, we order those 2 platforms to move in similar directions. But at the same time, we can take advantage of their mobility capabilities. The MTRS Inc. 2 can certainly traverse higher obstacles, steeper slopes, and has longer runtime than the GVR bot. So we can take advantage of that in our software. And then we can also take advantage of the Boston Dynamics Spot and how the different types of terrain, so that it can traverse over significantly more easily than the other 2 platforms, and how the Spot moves through the world as well. So Spot can move side to side. So we have that option in our autonomy. If you're on a platform where you can go side to side, we give that ability, so we can calculate and tell Spot to move side to side, left to right, upstairs, down ramps, things like that, all using the same software that tells a GVR bot how to move.
All of these payloads are developed to be IOP, physically mounted, plug-and-play capability. The only difference is that each payload, depending on the size of the payload, might not fit the platform uniquely. So in our redesign from the one we have on the GVR bot, we've done integration work and redesigned the payload to be more optimized to fit on the MTRS.